Good to see everybody. And yeah, pretty good crowd today. My goodness. Okay, nice. We were watching 2010. It's a follow on to 2001 Space Odyssey. Okay, who's old enough or wants to admit that they're old enough to remember 2001 Space Odyssey movie? Yeah. Oh, there you go. Okay, actually, there's 4 books. There's like 2001, 2010, 2061, and then 3000 or 3001 Final Odyssey or whatever. But they made 2 movies, 2001, 2010. I'll talk about that in a minute. By the way, back when I saw it, I'll admit that since it was in '68 and I saw it on a big screen, there was the theater was mostly filled with marijuana smoke. But that was the '60s. That's a long time ago. Okay, let's see. Saw it last year. Okay, so let's get started. So anyway, it got me thinking about, since we do the moon-based group every Monday, it got me thinking about what we had talked about in the moon-based group, and that is, oh, hey, one other thing is, for most of you guys, you already know this, but for anyone that may be new, is I love to have you chat while I'm talking. I will be talking. I do have slides. I can put stuff in chat, but I love to see what you guys are chatting about. In other words, I can read chat at the same time I'm talking because I pretty much know what I'm going to say. So, okay. So anyway, I was thinking about what we were talking about in the moon base, which was, in order to do a moon base, you got to get there. So I was thinking, well, how did we do that? And so I'd been researching for a while about how we got into space. Why? What were the incentives? How did we do it? That sort of thing. So that's kind of what this is all about. So let's get going on this. I will cover basically everything from ancient days. Well, okay, that was the incentive back in the '60s for sure. And I will cover from about ancient days up to around the '90s. And then next week, I'll cover from the '90s to today, and then a little bit beyond that. Okay, so let's get started. Okay, the first thing I did was I kind of came up with this, and it gives you an idea of, oh, yeah, at the end of the talk title. Okay. This is a big subject, and it's kind of hard to cover in about a couple hours, 1 hour this week and an hour the next. But essentially, you've got folklore. Well, space is big. And so you've got folklore going back thousands of years. And then folklore kind of went into science fiction and into science. In other words, when they started realizing how far the moon was away, that it wasn't, animate. There wasn't a man in the moon or a rabbit or anything else. And then science fiction, though. Science fiction has always been one of the ways which we use science and then also imagination, like folklore, and turn it into something that says, what if? Extend. Yeah. Oh, I forgot that the cow jumped over the moon. That sort of thing. I don't know if they found any cow remnants on the moon as it jumped over. Okay, so science fiction, though, is ongoing even today. Hopefully it's the final frontier, except, of course, atoms and all that stuff. We actually know more about space sometimes than we do about our own bottom of the ocean. Okay. Well, hey, Sumo, some cultures see the moon as feminine and others as male. It depends on what culture you're in. Okay, so anyway, science then led to rockets to weapons, which were also somewhat science fiction. And then rockets led to satellites. There were animal tests. Don't forget the poor animals. Okay. Um, and then satellites, we decided, go into orbit, and then space stations, and then probes to other planets. And then once you find out what Mars is about, and you're able to get into orbit, and then you do the moon landings, and then possible Mars landings and bases, and transport, commerce, all that good stuff. What, my laugh? Yeah. Okay, so the first part is dreaming of space. In other words, folklore, science, science fiction. Okay, so in folklore, now, the one thing, a dog, oh, okay, well, now there's dogs that have gone into space. There's one called Laika, for example, there you go, first dog to orbit the Earth. I'll talk about Laika here in a moment. So in folklore, for example, if you're in some Western cultures, you might have heard of Icarus. I know it was poor beast, because most people don't tell you what happened to Laika. Okay, so anyway, Icarus and his dad Daedalus there. Daedalus was an engineer. In theory, this is probably at least 2,500 years ago, and they were captured by the king of Crete, and so Daedalus gave Icarus some wings. He flew, in the way the story goes, he flew too close to the sun. It melted the beeswax of the wings. He fell into the sea and drowned. Okay, but that was long before they knew how close the moon or the sun was. And then in the moon group the other day, I asked about other folklores, and I was told about the tale of the bamboo cutter, which appears to be also a tale about the moon and being able to get to it and such like that. And then, of course, people started learning about just how far the moon was, and then understanding that the moon goes around the Earth and the Earth around the sun and all that good stuff like that. And then along came Newton, at least in Western technology, and posthumously in 1728, he said, kind of a thought experiment like Einstein did. He said, if you had a cannon on a tall mountain, and it was a big enough cannon, you shot it, and the cannonball would then fall to Earth. And then if it had even a bigger cannon, or you could make the cannonball go faster, it would fall further to Earth. And pretty soon it would keep falling, but it would go around the Earth instead of falling down to the Earth. And so does anybody happen to know how fast the cannonball would have to, falling, but keep missing the Earth as it fell? So to go around the Earth like that, in other words, to go into orbit, anyone know how fast you would have to go with a cannonball or anything else? Well, okay, and that's correct. In 17,000 miles per hour, or about 30, let's see, I think it's 30,000 kilometers per hour. Okay, and of course, science fiction has been in addition to ones for thousands of years. Okay, there you go. Okay, 8 kilometers per second, which is pretty darn fast. Yeah. Okay. Well, we can get into stuff. Okay. So anyway, science fiction. That's a very, very small example. I could do the entire hour on science fiction. And so you've got so I did a round off number there. Okay. So anyway, Jules Verne back in the 1800s, and then there was a movie in 1902 that was based on that. It was a very funny movie. You can find the whole thing on YouTube, called A Man in the Moon or whatever. Arthur C. Clarke, that's 2001 Space Odyssey. And then I asked at the Moon Group about some of the ones that are influencing people today. And they talked about one, the Red Moon, where essentially it was a Chinese on the moon as well as US. And then the For All Mankind makes an assumption that the Soviets landed on the moon first, and that everybody's been on the moon since then. So that's okay. So now 2001 Space Odyssey, since that was one of the ones that influenced me, these are some scenes from it, and it was very well done as far as science goes, and then kind of projecting ahead. Of course, it's way ahead of what we're doing right now. I would imagine we won't have. Um, I would imagine. Yeah, I saw the John Carter one and the movie, but I would imagine we won't have a space moon base like that for many decades, probably until the 2100s. But they imagined commercial flights up to a circular space station. The base was mostly under the moon's surface, and then they had a spacecraft to Jupiter's moons. Okay, so beyond that, when we actually reach space, let's talk about rockets, weapons, satellites, space probes. Well, they're going to have to be protected for sure. And there's lots of ways that you can do that. So in Newton's cannonball, the basic idea is that with sufficient velocity, you can send an object into an elliptical orbit. A circular orbit is just a instance of a particular instance of elliptical orbit, and then or escape Earth. And 1903, they usually say, okay, rocket equation was invented there, but actually it's as old as 1810. It's essentially a calculus problem that basically says that to change your velocity, relative velocity, say from 0 on the ground to getting into orbit and then to go to the moon or to go to Mars or to orbit or to get into a Lagrange point and stuff, it takes a certain amount of change in velocity. And that is, you have to have a certain effective exhaust velocity. And then it's basically how much propellant you have, and then how much does the spacecraft weigh. Okay. And so the change in velocity basically governs how much fuel you got to carry, which affects the total weight, and then how long it will take to get to the destination. The first object to reach space was a rocket called the A4 that was used as the V-2 weapon by the Germans in 1944. Space is defined as 100, at least nowadays, 100 kilometers up. Somewhat, in other words, it's somewhat ambiguous because there's nothing that, like, you just see space. I mean, in other words, you don't just cross a line, now you're in space. Okay, so you will notice on that equation, let me just back up, on that equation, the one here, we'll get a presentation on this one too, but that diagram at the very bottom shows all of the changes of velocity you would need to, say, for example, if you're on Mars, going to one of its moons, Phobos or Deimos, or going from Mars to the Earth, or going to the moon, or any number of combinations there. You will notice, however, because of the Earth's gravity, that if you were in Earth's orbit, it would take less fuel or change in velocity to get to the moon, to get to Mars, than it does simply to get into Earth's orbit. And particularly if you are, well, Sumo, actually, United States defines it as 80 kilometers, but internationally, space is defined as the von Karman line, which is at 100 kilometers, or about 62 miles. So it's ambiguous, but the fact is it's up there. And to get up there, to get into space, in this case, what they call low Earth orbit. GEO, by the way, is where the satellites, in other words, that's high enough up at where you are going around at the speed of the Earth so that the satellite appears to stay overhead, like weather satellites and stuff. That's what geosynchronous orbit is, GEO. But in any case, you need a big rocket to send something like a bunch of people and equipment and a moon lander and all that kind of stuff up into space. And these are some of the big rockets that have been invented over the years. You're looking at a lot of decades of difference here. Saturn V is one of the ones that actually, and they're all about the same height, by the way. So Saturn V was the one that actually did launch a spacecraft that was capable of getting to the moon. The Soviets built one, that's actually a mock-up, but the Soviets built one called the N1. But it was similar to SpaceX's, where it had lots of rockets at the bottom that had to coordinate. In the Saturn V, there's only 5 rockets at the bottom. But in this N1, it was very difficult in days before computers to coordinate those rockets. SpaceX has now been able to do it, even though their first flight didn't go so well. Yeah, I think it's 23.5 or something. But the idea is that you're going, whereas in Earth orbit, you are going around the Earth every 93 minutes or so. In other words, you see a sunrise and sunset every hour and a half, about 16 times a day, I think. The further out you go, you're still moving pretty fast, but the orbit is so large that essentially in the geosynchronous orbit, you appear to be stationary overhead as the Earth rotates. In other words, it takes 24 hours to get around that orbit. I will talk about the SpaceX in the next session, in part 2 next week. Okay, so you need a way to get there, like a big rocket, and then you need a reason to go. Because, why would somebody go into... Well, because the reason why there says you can answer that, but the idea is that if you're in the same plane, in other words, along the axis of the Earth, then you're synchronous. Otherwise it'll be more like a sinusoidal type of thing, and you'd have to technically speed up, slow down, and stuff to actually do it. So, yeah. But those are the types of things. Sis and Sumo are regular attendees at the moon base thing, and that's the type of thing that we talk about. Really interesting things. Okay, so anyway, you need a reason to do it. So let me go along. I'm watching my time, which is going by pretty fast. Let me talk about 2 characters here that were prominent in the first decades of space, which one was Wernher von Braun, and then he always wanted to go to the moon. So he started messing around with rockets when he was pretty young. In fact, only 18 around 20 or so. He started messing around with rockets. And one of the reasons he messed around with rockets, and one of the reasons Germany had V-2 rockets, was because in the Treaty of Versailles at the end of World War I, they mentioned things like battleships, and but they didn't know anything about rockets, or they didn't think about rockets. So essentially, it was a loophole in the Treaty of Versailles. And so Wernher von Braun had a little 4-foot or about a 1.4 meter rocket called the A1 back in 1933. And then he continued to build bigger and bigger rockets until the A4 in around 1940. And the Germans then, he used a combination of, and let me get my notes out here real quick. But he used a combination, if I remember, of water. Okay, he at first used, it was like kerosene and alcohol, something to that effect, or in other words, one that had oxygen and one that had basically a propellant. I could look it up, but then he added water to it later so that it didn't burn too hot and mess up the rocket. Okay, so anyway, by the 1940s, he had a rocket big enough to go to space. And so the A4 rocket was the first one. It actually went quite a bit up into space. It went 175 kilometers. But the Germans said, well, this is what's called today a intermediate range ballistic missile, IRBM. And if we stick a warhead on this thing, it can reach England. And so he didn't want it. He didn't want to use it for war, and the Gestapo actually jailed him for a while until he agreed to use it as a weapon, and so it became the V2 rather than the A4 during the World War II. And then, as my stepdad used to say, uh, yeah, oh yeah, well, they knew about chemical warfare back in World War One, but they didn't, to our knowledge. And if you know something different, I read that we haven't used chemical weapons or biological weapons on like ICBMs. It's all nukes. Okay, so he surrendered over onto the west side, and a lot of Germans surrendered over onto the Russian side. And he worked with the U.S. Army on ballistic missile during after World War II, and then Disney. This is kind of a funny one. I like to, the real stories are much more interesting than just blah 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 events. And so actually Disney was building Disneyland, and he had things like Adventureland and what else does Disney have? It's got Adventureland. It's got but he was talking about tomorrow. Well, no, this was Disneyland, like 1955 Disneyland. Before that, but anyway, yeah, that early Disneyland, Cafeteria Land. Well, definitely, you got to earn money somehow. But it was Adventureland and Fantasyland or some other thing like that. So anyway, he also had Tomorrowland, but he didn't really have a good concept of what to put in Tomorrowland. So Werner von Braun was a very well-known figure at that time, and he got together with Werner von Braun, and they made 3 films that were Disney films. This is a comic book version there, and one was called Man in Space. Now, I called mine Humans in Space, Tantrum. That's only for the little kids and for some of the adults that haven't grown up. Okay, but in Tomorrowland, he actually had Werner von Braun describe the rockets. You can actually find these. If you look up like Tomorrowland Disney thing, you'll see Werner von Braun talking about rockets that go into space and go to the moon and Mars. And one of them basically has a rocket or a spacecraft with wings on the front of it. So it's kind of like a space shuttle on a rocket. And so he kind of was predated that one also. So, and then once the space race got started, he also was the one that designed the Saturn V and for the first moon landings. Now, on the Soviet side, okay, on the Soviet side, you had Sergei Korolev, and he worked, first of all, he worked with the Germans after the war to replicate the V2, which then became the V1. And he also worked in ICBMs, and the R7 rocket was the one that launched Sputnik, which was the first satellite. And then Luna 1 was the first one to try to get to the moon in 59. It missed the moon by about 1,000 kilometers, but Luna 2 hit the moon. And also the first humans into space, the first flyby Mars, the first craft on Venus. And then he died around 80 or 66. And it really, because he was the architecture of the program, architect, he kind of disrupted the Soviet efforts to get to the moon. The other thing was the N-1 rocket, which I described. But back in those days, people were not nearly as jaded as they are today. And people were really wanted to know about science and science fiction. And also space travel was a big deal. Now it's like, oh, we just landed on Mars. And people go, ho hum, what else is new? They'd rather know about what's happening on TV or something. Okay. So anyway, for the visions to become, yeah, or denied. Well, I remember back when they landed on the moon, is there were a lot of people going, nah, that didn't happen. Not the moon I see at night. It's a television show. I mean, television program, that sort of thing. Okay. So visions becoming real is Arthur C. Clarke was the one that first conceived of communication satellites back in 1945. In other words, like the Sputnik. Eisenhower, U.S. president, in 1955, announced that the U.S. would be launching a satellite during what's called the International Geological Year. But instead, the Soviets launched one, and the U.S. was very surprised. In response, now why? Okay, why is a satellite a big deal? You can put it in chat. I mean, why were people there was why launching Sputnik? I mean, all Sputnik did was just go beep 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 at 20 hertz. Yeah, Cold War. In other words, if you could launch a satellite, it was like an ICBM. In other words, you could drop a war, exactly, military space, all of that stuff, weaponized. Absolutely, that was the thought back then. Okay, so the U.S. response was to establish NASA, and then also DARPA. DARPA was the agency that has invented all kinds of stuff. They were in the 2000s. They were the ones that initiated the driverless car as a contest. They also invented the internet back in 1971. That's just two of a whole list of stuff. Okay, and then President Kennedy basically challenged the country to land a man on the moon. And I'm using the word man because the first woman, okay, does anyone know who the first woman was in space? And about when she went up. Okay, so Kennedy said, hey, let's go to the moon. And it wasn't like, what's in it for us, or what's our return on our investment, or, well, well, she could have been. Yeah, there we go. Okay, you're getting close. There was a lady in the Soviet Union named Valentina, and I'm trying to remember, but it was like Tereshkova. But it was there you go, Tereshkova, 1963. Very good. On Vostok. Vostok was the sixth version. The Vostok 1 was the first one that went up with Yuri Gagarin. I'll talk about that in a minute. Okay, so anyway, as I mentioned, rockets became ICBMs, and the ICBMs launched spacecraft. And then the geophysical year. Now that International Geophysical Year, I don't want to go, like I only have an hour for this whole thing for today anyway. And so the geophysical year was actually something started back in the 1800s. 1882, it was the International Polar Year. And so so they continued talking about the poles. So the Antarctic Treaty that we have today was actually established during that same International Geological Year. And it also helped to define the mid-oceanic ridges for plate tectonics. The latest one was in 2007. A lot of stuff, 135 different experiments, lots of countries. And then the next one is in 2032. Now, the interesting thing in the 2032 is that I suspect that'll be about the time of the first moon bases. And depending on how it's funded, it may be a Chinese moon base. And let me, animal test orbit, Earth's orbit, first moon landings. So, as mentioned earlier, it's not hard to, in other words, the first reasons for why we went up into space were pretty simplistic. It was a matter of proving which world view was superior. And yeah, it was a disguised military effort. And the players and incentives it was a lot simpler. It was essentially the US and the Soviets. But that's not entirely true. And I will talk about the Chinese program very early on next week, because they actually had a moon program starting in 1965. It's just that it got canceled in 72, because if you know what was happening in China in 72, there was a big political change and upsets during that. Yeah, exactly. During that time period. And then so they didn't get kind of back in business until the 90s. Okay, so let's talk about then some of the now we're actually man in space, or humans in space. We've already said that. Okay, so humans in space. And so the Soviets actually had a lot of firsts. Um, oh, that was such a good movie. And then they did a remake of it too. Klaatu, Barada, Nikto, or let's see. Anybody know that one? Okay. So anyway, Yuri Gagarin. Yeah, there you go. Okay, Gort. Okay, so Yuri Gagarin was the first human in space. Now, let me tell you a little bit about here. I'm watching my time here, but for Yuri Gagarin, what they did was, first of all, that's the capsule up on the right top side. And you see that, you got to get crammed in there. Does anyone know what else was in that capsule? I like real world stories much better than just events like he went into space. Yeah, there was a parachute, not necessarily in the capsule. Well, probably had vodka. By the way, the details of the Soviet program was not made public until at least '89, when perestroika, and then after the dissolution of the Soviet Union. And so we didn't know a lot of these details for quite some time. So anyway, there wasn't a lot of room, but most of the capsule, a lot of the capsule was food. And the reasoning was, okay, he launched, and then he went around, and they didn't have any satellites or any relay stations and stuff at that time. So he had to use HF radio communications. And a lot of the communications was, hi, I'm alive, and I'm alive again. And we're going over Hawaii, and we're going over South America and all that. And a lot of the communications did not get back to the base. And one of the things that had to happen for him, yeah, view is great. So one of the things that had to happen was that a retro rocket had to fire to slow down the capsule so that it would then enter the atmosphere and land with the parachute. There were some times, by the way, in one of them, there was actually a window at their feet. So you were looking down at the Earth. And then that one looks like it has a window in the side. But in any case, if the retro rocket did not fire, does anyone know what would happen? Well, he would become a big meteor. And so there was about 15 days worth of food. And the 15 days worth of food was about the amount of time that the spacecraft would need to get down into the orbit so that it would get an atmospheric drag and burn up. So in other words, they wanted to make sure that he had enough food to last for 15 days so he didn't starve to death first before he burned up. But that didn't happen, and he came home, a hero. Now, the Voskhod was the next. This is the Vostok program. There was about 6 flights. The Voskhod was one where there was a backup retro rocket, which is a good idea, and then also an exit, so when it was easier to get out of the spacecraft. Okay, so the U.S. program also had a parallel program. That's John Glenn. Alan Shepard was actually the first person to do a suborbital. The Soviets went straight to orbital. Well, water probably would have been a problem in 30 days too. I'm not sure how much water they had. Now, Briony, hold on to that thought, the nausea-inducing one, because that becomes a problem with Apollo 8 and some of the other ones. So hold on to that thought for a second. So the U.S. had parallel programs. The Mercury one, which was essentially, could you survive in space and actually function with people? John Glenn was the first American in orbit. By the way, he went up later, decades later, with up to this ISS. Decades later, after he'd already become a senator and all that stuff like that. Okay, so there was the Mercury program, the Gemini program, basically that were testing Yeah, it was pretty. He wasn't a young person anymore. Testing equipment, developing techniques needed for Apollo. But we don't want to forget the animal test program. So I'm going to talk a tiny bit there. Well, yes, he was. He had the right stuff. There's a movie. He was one of the 7 astronauts that were test pilots. Okay, so animals in space. Anyone want to answer the following questions? I'm watching my time, so we don't run too far. I'm probably over time a little bit. Anybody want to answer any of those first questions? Well, actually, I didn't read anywhere where they sent a bird up. If you can find that one, I'd like to know. Okay, so the first Earthling to leave space was, and I'll write it in. Okay, they did send fish, a fruit fly, and they did do mice. But the first Earthling to leave space was in a V2 rocket in a fruit fly. A fruit flies in 1947. Okay, first mammal to survive space. So anyway, rather than have to guess all this, here's some answers. Okay, so Laika is on number 3. So you had in 1951, they sent a dog up. Now, unfortunately, most of the dogs they sent up did not survive. The first animal to orbit was Laika, but there was no way to recover Laika at that time. So essentially, Laika died in space. Sad, because I knew Laika. You know, I mean, I didn't know Laika, but Laika was a mongrel they picked up in the streets in Moscow and then put in the spacecraft. But even I knew about Laika back in the 50s, 60s when I was in school. Okay, so look at all the other stuff. Apollo 17 had 5 mice that were named Fee, Fi, Fo, Fum, and Fooey. They sent up frogs and rabbits and chimpanzees and guinea pigs and rats and wasps and fish and spiders and chicken eggs and turtles, lots of turtles, worms, beetles, blah, 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 blah. Okay, and tardigrades. One of the latest spacecrafts had over thousands of tardigrades, and they might still be alive on the moon because tardigrades, we get tough. They actually found tardigrades on the outside of the ISS. Okay, let's talk about Apollo 8. Just like I talked about Yuri Gagarin's flight, is Apollo 8 was supposed to be just another test flight. Now, this is a cool story, so I hope you can hear. Apollo 8 was supposed to be just another test flight after Apollo 7. Oh, no. Okay. I'm not reading chat. No, I am. I can't unread that. Okay, so anyway, Apollo 7 was supposed to be another test flight, but the Soviets had already been sending spacecraft to the moon. And on one of them, true story, they put a recording that sounded like it was people that were circling the moon were going to land. And so the US thought that the Soviets were not only going to beat them into space, the first person in space, the first woman in space, the first one to Mars, the first one to the moon, the first spacewalk, all of that, but we're actually going to land on the moon before them. So they kind of upped their schedule a bit, and they told the Apollo 8 people, hey, guess what? You're going around the moon. And even the Apollo 8 astronauts thought that there was only about a 50-50 chance of making it back alive, but they said, okay, let's go. And so they launched. Now, at that time, what they do is they launched. There were several sections. The LEM wasn't even completed, so it was a mock-up of the LEM, the lunar landing vehicle. But they did check it out. They went and they turned around and practiced with that, and then they realized, the fourth stage of this thing, we might hit it, the fourth stage of the Saturn V. So they did a maneuver to get away from it, so they wouldn't hit it. And then they went to the moon. They went around the moon about 12 times. By the way, it was fogged. The outside of the spacecraft, the windows were fogged up, so they never saw the moon until they were on the far side of the moon. One of the astronauts, about a third of the astronauts, get sick in weightlessness until their ears get adjusted. So imagine this was not made public, but one of the astronauts both threw up, vomited, and had diarrhea. And you can imagine in a tiny little capsule like that, over many days, little droplets of vomit and diarrhea floating around the capsule that they would have to clean up. I know, how delightful. But only one of them, no AC, no, nothing like that. So they had to clean up. I know going to space is not like Disneyland. Yeah, well, about a third of the people suffer from space sickness. It's just something that their inner ear has to get used to. Okay, so anyway, they went around the moon, and then they saw this on the day before Christmas. There's Tagline being the doctor, giving us a good explanation. But Earthrise is very difficult to see. I'm still watching my time, because you actually have to be orbiting the Earth to get a sense of the rise. Because if you're on a moon base, remember that the moon, what actually, if you're near the South Pole, for example, the Earth rises very slowly. It takes about 2 weeks for it to go from the surface up to where just about that high, about 5 degrees up, 5.5 degrees actually, and then or about a week to go up, a week to go down, and then below the horizon, and then 2 weeks out of sight, and then coming back up. So there is no sense of rise like there is moon rise on the Earth. The Earth is also 4 times as big as the moon. So seeing the moon as moon rise was very dramatic to the Apollo 8 crew. The reason they read, by the way, does anyone? Yeah, but those are the variations. In other words, I have a video by NASA that shows what it would look like. In other words, it's very similar to actually on 2001 Space Odyssey. If you looked at the pictures back there. I didn't know this either, but it depends on where you are. In other words, it would be fixed in the lunar sky if you were at particular parts of the moon, but depends on whether you're South Pole or, that sort of thing. But it's because of the inclination and the 1%, in other words, and stuff. Okay. Anyway, okay. So anyway, where was I? Okay, so does anyone did anyone remember, did you happen to hear, like I did, Apollo 8 on Christmas Eve? One of the astronauts read a passage from Genesis in the Judeo-Christian Bible, and the reason why is because he was supposed to read. It was Sunday, and he was supposed to read, he was supposed to read at his church. And he said, okay, if I can't, I'm in space. I can't read at the church, so I'm going to read from Genesis. And so that's why he read from Genesis on Christmas Eve as they came around the moon. And then, of course, they came back. They landed safely, all that good stuff like that. And then the first moon landing was in Apollo 11, which was the next summer. That's Buzz Aldrin to the left. By the way, I went to my multi-year past 50th high school reunion recently, and one of my friends in high school worked for NASA after college, and then he worked with Buzz Aldrin for 15 years, and so he knew Buzz Aldrin quite well. That's Buzz Aldrin on the left over there, and he gave me something that I will show you next week that he and Buzz Aldrin and a bunch of people worked on. Okay, and you can see the blue marble, so to speak, there down at the bottom. By the way, NASA just recently awarded contracts to a couple companies to build a new kind of moon buggy. And you can see up to the upper right the command and service module, or CSM. The only thing that actually comes back to Earth is the little nose cone there at the bottom of the picture there. And then you have the LEM, or the Lunar Excursion Module, with 2 parts, the one that landed on the Earth and the one that then took off. So there's multiple parts in here. And next week we'll talk about what they're planning the next time around. Okay, so now beyond Earth, once they actually had enough hardware, so to speak, for 9 landings. But after Apollo 13, they got kind of antsy and they canceled the last 2 landings, also because of budget and stuff. Okay, which is very low. Okay, we'll talk about that sort of thing next time around. Okay, space stations, transports, diversity, all that good stuff. Okay, so the first space station actually was, again, a Soviet first, which was the Salyut for 1 in 1971. There's a diagram of it on the bottom right, and then the actual first one in, and then the next one that was U.S. one was Skylab. You can see that they're very similar. There's a place to land in the bottom. In the Salyut one, you can see a Soyuz spacecraft, and then up in the Skylab, it was actually one of the Apollo ones that were left over that they were going to use for moon landing. And then you've got an airlock, and you've got solar panels, and you have a research area. And so these were the first, they're small. Now, when they say deorbited, what does that mean, anybody? In other words, the Skylab went up in 1973 and deorbited in 1979. Yeah. In other words, it was pretty low. Well, re-entry as in burn up. In other words, fall out of the sky as in fall very slowly out of the sky and burn up somewhere over the ocean is essentially what re-entry means. Okay, now the Soyuz program that the Soviets had was probably the most enduring of all programs. It had over 2,000 launches from 1967, and they still are launching. In fact, from the end of the space shuttle till the SpaceX had the Space Dragon in 2020, it was the only way to get to the International Space Station. Skylab helmets. Okay, really? Okay. So anyway, I'll do not shut your eyes, but try to focus. I still have a little bit of vestibular problems at night sometimes when I get out of bed, that sort of thing. But that's because I'm old. Okay. So anyway, the Soyuz program, after in 1970s, they had a little bit of detente where Americans went over to China and Russia and all that good stuff. And so they started having some, for example, the Apollo met up with the Soyuz docking and stuff as early as 1975, that sort of thing. Okay, then we had in the US, we had the Space Shuttle. Now, the next programs like the Space Shuttle and stuff, there were more astronauts other than just Soviet astronauts and US astronauts. The Soyuz, for example, had people from the Soviet bloc that went up there. And I'll get to that here in a second. And then the Space Shuttle ran for 30 years. And there was 133 successful flights, a couple very well publicized failures that people tend to remember exactly where they were, like on the Challenger explosion, things like that. But it was also reusable spacecraft. It would land, Space Shuttle, as a big glider, much like von Braun had pictured. And it also was able to move around by itself, and it had a bay that it launched things like the Galileo spacecraft and the Hubble Space Telescope and Venus probes and the Chandra X-ray telescope and stuff. So it was a good way. It was a shuttle. Its technical name was the Space Transport System. So the flights were all STS something. And like I said, there's 133 and it went all the way until 2011. In fact, the one you can see there, that's one of the shuttles that's hooked up to the ISS in 2011. So it was also a very, like the Soyuz program, it was a very um, um, successful program, and they had people from lots of different places. You can read right there with Russia and the Ukraine and Saudi Arabia and Mexico and Israel and Germany and Canada all going up on the space shuttle. Now, one of the things about the space shuttle for the US was up until the space shuttle, essentially, you were talking about military officers that went into space. Yeah, I'd love to have a space elevator, particularly on the moon. That would be cool. Um, I think it might be more practical on the moon. I'm not sure. S is says S is okay. So anyway, um, one of the things, like I said, most of the people who went up into space with the Apollo program and all that were military officers, males. And so the space program, one of the things, does anyone recognize the person to the left? Yeah, exactly. Okay, so she actually played a big part. I don't know if you know the end, and I have 5 minutes, and I'm close enough to the end that I can share this story. If you don't know the story, when she was playing, yes, that one right there, that's the story. In other words, when she was in Star Trek, she was going to quit, and she got a knock on the door when she was backstage, and what the people said, one of your biggest fans is at the door. She says, well, okay, great. Yeah, let him in. And it was Martin Luther King Jr. And he says, look, you can't quit. Don't you understand? Is that right now on television and in the movies, African Americans or Black Americans are portrayed as servants or, you know, uh, in other words, as less than people. And you are an officer on a spacecraft and people depend on you and stuff. And he says, I know, it's a fictitious role, but you can't quit. It's important. And so she stayed on with Star Trek. And then after Star Trek, she used, well, exactly. Um, and then, yes, even more so, as maids or stuff in that day. And so Nichelle Nichols, after Star Trek, used her fame to talk to NASA and others about diversifying the astronaut corps. And she helped to get Sally Ride, who was the first female astronaut, and then first Asian, first African American. She helped to refine who it is to be an astronaut. And that was extremely important for the United States. Okay. And then finally, and this is my last slide, so I'm doing pretty well in wrapping this up, is that this is the Mir space station. Now, a lot of people may not remember this one. This was from 86 to 2001, and it also deorbited. There were some big pieces that fell in different places on Earth. Well, see that, Sumo, you got it on the head there. Is that during the Cold War they had a Russian, they had a Japanese, they had Americans, they had a black female, they had a alien, Spock. I mean, it was well ahead of its time and with respect, and we had solved the world's problems and all that stuff like that. So okay, so the Mir space station. Well, I thought so, and the fact that no, he was not on board Star Trek. He wasn't. Okay, so anyway, here's the Mir space station, and the Mir also, well, it does. It can mean Mir, can mean peace or world, depending on how you, or Mir the Mir, world peace. You can, depending on how you use it. But the Mir space station did a lot of research. It was up for quite some time, about 15 years, before it came down in pieces and burned up. And you look at all the different people that went aboard it, including people on space station, on the space shuttle, like I mentioned, and people from Europe and all over the world, essentially, that went up onto the Mir space station. Oh no, Sis. I guess they didn't have any mirrors in Mir. Okay. But it was highly successful venture as well. Okay, so we are at the top of the hour, and I will then talk about humans in space, starting with the Chinese space program and the International Space Station, and all of what happened in the last 20 years. Okay. Yeah, as I mentioned, Mir also means world, so you can have Mir Namir, world peace, and you can have. Okay, thank you.